Welcome back, guys. Today we'll be doing finding the particular solution for the differential equation e to the 2x y prime equal 2x plus 4 times y cubed, where we're given a particular solution where x is 0 and y is 1 over square root of 5. So we're going to find the particular solution for this differential equation. But first, find the general solution before we can go ahead and look at the condition so we can go and find the particle. Step 1, let us find the general solution. As you can see, we have e to the 2x y prime is equal to 2x plus 4 in bracket times y to the 3. Looking at this is a first order differential equation because we have y prime. And we can also see that we can separate the variables where I can put the e to the 2x on the right hand side and y cube on the left hand side. Now I'm going to change y prime because y prime is the same as dy over dx. So I will be rewriting it as dy over dx. Then I have e to the 2x here is equal to, open bracket, 2x plus 4. Then I multiply by y cubed. Separation of variable means that I get x on one side and y on the other side. So the norm is for us to get y on the left and x on the right. This is e to the 2x, so we have to get it on the right. So we will divide both sides by e to the 2x. That's the only way I can get it on the other side. So I divide both sides by e to the 2x. Now, e to the 2x into itself, it cancels. It goes into itself and it goes 1 times. So what we have is 1 dy over dx, or we could have just left it as dy over dx is equal to 2x plus 4. Now, although I have this in the denominator, we can change the position. We can rewrite this so that we have this in the numerator. So it means I change the sign of the power. So it now becomes e to the minus 2x y cubed. So all I did was just rewrite this. And it's using the laws of indices. The laws of indices says that when we have 1 over a to the n, if I'm going to change the position, then the sign of the power will change, in this case from positive to negative. So that's what's happening right here. We change this to negative 2x. So the minus tells me that I can rewrite it, and it basically goes in the denominator using this indices rule. We're not finished because separation of variable means x on one side, y on the other side. So this y cube, I need to get it on the left. So what I'll do, I'll divide both sides by y cube. So I divide both sides by y cube. So this cancels. So what we have over here is 1 over y cube dy over dx is equal to 2x plus 4 multiplied by e to the minus 2x. Now, 1 over y cubed, we can apply the same indices rule. We can rewrite it as y to the negative 3. Now, I'm also going to do another step. getting dx on the other side, because remember, separation of variable means all the y's on the left and all the x on the right. So dy is on the left and I need to get dx on the right. So to get it on the right, I will multiply both sides by dx. So I multiply both sides by dx. So these two cancel. So in other words, what I have here is just y to the negative 3 dy is equal to 2x plus 4 e to the minus 2x dx. Now here, as you can see, we can now go ahead and integrate. So integrating, because we have variables being separated. Now integrating y to the minus 3, we're just going to add 1 to the power. So integrating this with respect to y, I will have y minus 3 plus 1, that's negative 2. And would also divide it by the same power, which is minus 2. Just remember the rule is, if I have y to the n, then integrating this, I will have y to the n plus 1 all over n plus 1. That's the integration rule. Now over this side is not that simple, because here we have two functions being multiplied. When we have two functions being multiplied, we have to use integration by parts. So to integrate with respect to x, I'll have to use integration by parts because we have two functions being side by side. So applying integration by parts, so I'm integrating 2x plus 4 times e to the minus 2x dx. Now what I'm going to do here, I'm going to assign, I usually say to my students, the easier one, the one that we can differentiate to get a constant to be u. So in my case, my u will be the 2x plus 4, because I know when it differentiates, I'm able to get a constant. So it means my v prime, where some persons write dv, will be e to the minus 2x. So differentiating 2x plus 4, I will arrive at 2, because the differential of 2x is 2 and the differential of 4 is 0. To get v prime to be v, we will have to integrate this with respect to x. So to integrate an exponential function, we use the integral of e to the ax is equal to 1 over a e to the ax. So integrating e to the minus 2x is going to be 1 over minus 2 e to the minus 2x. Now we're going to apply the formula. By parts formula is the integral of uv prime is equal to uv minus the integral of u prime v dx. This is the formula that we're going to apply. So here I'm going to insert what is my u. U is 2x plus 4. What is my v? V is 1 over negative 2 e to the minus 2x. minus, what is my u prime? U prime is 2 and v is 1 over minus 2 e to the negative 2x dx. This negative a half will affect what we have here. If I multiply all of this by minus a half, because this is a product, so getting a half of this, it will definitely reduce. So a half of 2 is 1, but because of the minus, in other words, negative a half times 2x, that will be minus x. Minus a half times 4, that's minus 2. So all of this is being reduced, and then I have e to the minus 2x. Same case here, 2 cancels the 2, but the negative sign here, the negative sign is affected right here, so it changes to a positive. So what we have is plus integral e to the minus 2x dx. Now we're almost finished with integrating it by parts. So it means the answer for the integral of 2x plus 4 e to the minus 2x is minus x minus 2 e to the minus 2x. And then integral of this will be, remember we did something like this already, it is a minus a half e to the minus 2x. So this changes, so it becomes minus a half e to the minus 2x, and now we'll write our constant c. So right here, the integral will be minus x minus 2 e to the negative 2x minus a half e to the minus 2x plus c. And this is what we call the general solution. So this is the general solution. Let us find the particular solution. So now we're going to find the particular solution. This is the information that we need in order to find the particular solution. When we have it looking like this, if you realize it says y of 0, it's like in functions. When you were learning functions, if I say f of 1, you're able to say x is equal to 1. It is the same case here. When we have y of 0, this is saying x is equal to 0 and y is equal to 1 over root 5. So now we're going to substitute into this function what I have for x and y. And doing this, we will find c, which will give us the particular solution where we have the value for our constant. So substituting, I have y, which is 1 over root 5 minus 2 over minus 2 is equal to, now x is 0, so I'll have minus 0 minus 2. Then I'll have e to the minus 2 times 0 minus a half e to the minus 2 times 0 plus c. Now let me work this side first. We know that this will be minus 2, but minus 2 times 0 here, by right, this will be 0. And anything raised to the power 0 is 1. So 1 times, this will be negative 2. That will give a minus 2. I repeat, minus 2 times 0 is 0. E to the 0 is 1. 1 times negative 2, that's minus 2. Same scenario here. This will give us 0. E to the 0 is 1. 1 times minus a half would be minus a half plus c. over this side can be calculated on your calculator, or we can do it as such. Now 1 over root 5 to the negative 2. That's what we're doing. We know that we could rewrite this as 1 over, once I'm going to write a fraction, I change the sign. So it is 1 over root 5 all square. So in this is rule, if this is negative and I'm going to change it as a fraction, I change the sign to positive if you're not using your calculator. Now I'll square all of this, so I'll have 1 over 1 square is 1, and square root cancel the root, so this would be 5. And we know when we have a fraction in the denominator, I will reciprocate it, or in other words, flip it, so it becomes 5 over 1, which is 5. So this in the numerator is the same thing as 5, and then the denominator I have a negative 2. Now minus 2 minus a half is actually negative 2 and a half, which is the same thing as 2 to the 4 plus 1 is 5. So that's minus 5 over 2. So by right, all of this is actually negative 5 over 2 plus c, and this is also 5 over 2, and then I put a minus sign. So just to show you that they're the same thing. So carrying this over, it becomes positive. So I have minus 5 over 2 plus 5 over 2 is equal to c. So that means c is equal to 0. Therefore, my particular solution is y to the minus 2 over negative 2 is equal to minus x minus 2 e to the minus 2x minus a half e to the minus 2x. And we will not have a plus c because c is 0. And this is our particular solution. Thanks for watching, guys. Don't forget to subscribe to my channel. Have a great day.